Our next topic, the Schmitt-Trigger circuit. In an analog comparator circuit, applied input voltage is compared to the known reference voltage. The output voltage will be the square pulse. If the unwanted noise voltage is present in the input signal, then output voltage waveform is not a square pulses. uh, some unwanted signal will be present in the output voltage. This is called chattering. And from this problem, avoiding this problem, we are use the Schmitt-Trigger circuit. Again, I say when the input voltage is applied for the comparator circuit with respect to the reference voltage, the output voltage will be the square pulses or square pulses of the from the input signal. When the applied voltage is sinusoidal signal, the output voltage will be the square pulses. This is the comparator output. But when input voltage, some unwanted signal is present, some noise signal is present in the input signal, then output voltage will be square pulses, but some rapid pulses, some pulse with this increase or some pulse with this decrease. That's mean duty cycle is change. Now avoiding this problem, we are use the Schmitt-Trigger circuit. The Schmitt-Trigger, this one is the Schmitt-Trigger circuit. There the feedback resistance is applied the non-inverting terminal. This is the main difference between the op-amp and Schmitt-Trigger circuit. General op-amp we are applying the feedback resistance is inverting terminal, but their feedback resistance is used the non-inverting terminal. Here the input voltage V in or V in apply the inverting terminal to the resistance R3. Suppose the output voltage V0 is equal to when the output voltage V0 is equal to plus Vsat. When the output voltage V0 is equal to, suppose output voltage V0 is equal to plus Vsat. The feedback voltage through the resistance feedback voltage of non-inverting op-amp through the resistance R2. We know the voltage divider rule. The R2 divided by voltage across the R2 is equal to R2 divided by total resistance R1 plus R2 into plus Vsat, output voltage Vsat. So VA will be R2 by R1 plus R2 into plus Vsat. And this one is, suppose this one is equal to V of ut. One upper threshold voltage. V of ut. The V of ut is equal to R2 by R1 plus R2 plus Vsat into Vsat. This is called V of ut, upper threshold voltage. There are some cases. In case when the V input is less than of VUT, input voltage is less than of upper threshold voltage, then output voltage is constant. That's mean the graphical representation of this V0 and input voltage V in. When the input voltage is less than VUT, feedback voltage, then V0 is equal to constant plus Vsat. V0 will be constant plus Vsat, constant at plus Vsat. Suppose it's plus Vsat. Suppose this one is plus Vsat. Again I say, when the output voltage V0 is equal to plus Vsat, then the feedback voltage of non-inverting op-amp, non-inverting input terminal Vf is equal to R2 by R1 plus R2 into plus Vsat. Voltage through the resistance R2, voltage divider rule, R2 by R1 plus R2 into plus Vsat. This one is V of ut. This one is the V of ut. Upper, that's mean V of upper threshold voltage. The case one is when the V input voltage less than upper threshold voltage, then output voltage V0 will be the constant of plus Vsat. When the second condition, when input voltage is just greater than the reference voltage, V of ut, input voltage just greater than, not greater than, just suppose equal or just greater than 0.001, then plus Vsat is switched from plus Vsat to minus Vsat. Plus Vsat to, suppose this one is minus Vsat. switch from plus V set to minus V set. When the input voltage is just greater than the V of ut, switch from plus V set to minus V. Third condition, when the input voltage is greater than, just greater than of VUT, then V0 is equal to constant minus V set. This one is the upper threshold voltage output diagram. When the, suppose next condition, when the V0 is equal to minus V set, when the V0 is equal to plus V set, no, minus V set, that's mean the feedback voltage of non-inverting terminal VF is equal to minus R2 by R1 plus R2 into V set. When the input voltage, when the output voltage V0 is equal to minus V set, the feedback voltage VF of non-inverting terminal minus R2 by R1 plus R2 into V set. This one is called V of LT, lower threshold voltage. There are some three cases. When V input is greater than VLT, the output waveform, when this one is the V0 and this one is the input voltage. When the input voltage greater than VLT, lower threshold voltage से ज़्यादा है, then output voltage will be minus V set, constant minus V set. A minus V set, a suppose plus V set, a minus V set. This one will be the minus V set. When input voltage just less than VLT, then the output voltage switch to minus V set to plus V set. Minus V set to switch to minus V set to plus V set. Third condition, when V input is less than VLT, then this constant plus V set. This one is the second condition, when the lower V0 is equal to minus V set. So complete graph of the Schmitt-Trigger circuit will be this type of V0, V in for V plus V set, for plus V set, and this one is the for minus V set. This one is the complete graph of Schmitt-Trigger circuit. Okay. Now the difference between upper threshold voltage and lower threshold voltage. The difference between upper threshold voltage and lower threshold voltage. This one called hysteresis with V of H, width of hysteresis, is equal to V of UT minus V of LT. UT is equal to R2 by R1 plus R2 V set minus of R2 by R1 plus R2 into V set minus plus. So 2 R2 by R1 plus R2 plus V set. This one is the hysteresis width of a Schmitt-Trigger circuit. Thank you.